Hello, thank you. And yeah, I am between you and coffee, and that's very uncomfortable. Um, but we'll see if we can get through it. And here is the clicker. Right, so thank you again for letting me come here and speak to you. I am Nina. I work for Kentik. And in this talk, I'm going to be talking about a topic or a method that a very old friend of mine, who is also one of our customers, came up with on trying to, what do we need to do to fight DDoS at the source of the attacks? So the whole topic is looking at spoofing and looking at the DDoS attacks that are reflection attacks. What we claim, Aaron, and the very dear old friend of mine is Aaron Weintraub from Cogent. So he is basically a method of his that he does in his day-to-day job that I'm going to be talking about today, and that he told us about a couple of, well, I think sometimes last year. So first, a quick recap. I know most of you in this room will absolutely know more than I do about reflection attacks. But for those who don't, we'll just give a brief overview of what we do. So what happens is that somebody decides to attack, and the way they do it is they send thousands of requests with spoofed IP addresses. So they send it to DNS servers that are not patched, or NTP servers, or other types of servers that gives replies. And then the reply is not sent back to the origin of the request, but to the spoofed IP address, which is then the target of the attack. So that is, in short, what is going on. And many enough of that does it, and you get a degraded or unavailable service. So one of the largest ones that we've seen of that, and somebody might correct me if this is not the largest one, is a reflection attack that happened to Google Cloud in 2007. And they told us that that attack originated in 4 Chinese networks, and it's these ASNs. And the attacker used these networks to spoof 167 million packets per second to 180,000 exposed DNS, CLDAP, or SMMP servers. And all the responses from all of these servers then went to Google Cloud targets. And at the peak of the attack, they were seeing 2.54 terabits per second, which I think we all can agree in 2007, but also today, is a massive amount of traffic for a DDoS attack. So what can we do to prevent this problem? Well, one is make sure that the servers are as up-to-date and as hardened as possible for receiving the bad kind of traffic, or eliminate the spoofed traffic on the network, which is using technical means like BCP38. And finally, which is what Aaron has been thinking about, what to do with the rest, with those who do not engage in, or with those who do not want to implement or can implement BCP38 or anything. And what is BCP38? Let's just make a recap of that, especially if I press the right button. So it's basically source IP verification. So it checks when a packet arrives at an interface, it checks, is this packet allowed to arrive on this interface? And you can implement it different locations in the network depending on what type of network you are. So if it's an access network, where there's definitely no downstreams or anything, you implement this on the interconnection down to the end user. Or you can implement it on the edge to the neighbors of that network. Or if you are a transit provider, it is on your customer interfaces that you need some sort of source IP verification. And the different types of those is the SRFP, which is the strict one. And those only work when you have symmetric routing. Or you can do the feasible reverse path forwarding, where the check is, do I, on this interface or on this router, do I have a route to this address or not? And if you do, you allow the packet, or otherwise you do not. This works for ISP networks, but there is a risk of blackholing, and that's why some people do not want to do it. Because if somebody downstream is using traffic engineering by retracting their prefixes, you might blackhole the traffic. And finally, you can keep access control list on your interfaces. But again, here, even though we automate a lot, there's a lot of maintenance. So these are all the good excuses that people have for not doing this kind of check and for allowing spoof traffic in the network. So what Aaron came up with, or what Aaron is doing, is that he says, well, I have NetFlow, so I can use that tool to figure out when do I see spoof traffic coming into my network, and then basically go and yell at the people who allows it to come there. So I'm going to go through the method that he's using in the tool that he has. First of all, you have two steps. You find the spikes of traffic from customer networks to large destination of IP addresses that are using ports that are usually abused. So that's the first identification you need to do, figure out what are those ports, and then go have a look at your traffic and see, do I see any of those suspicious spikes? Then when you see a suspicious spike, you go drill down to the selected UDP ports and then look at the source IPs for that traffic and figure out what ASNs do these source IPs come from. So let's have a look at that in detail. So the first query that you run, and I hope that you can see what is on the query screen, otherwise we have tried to spell it out in text. You go only to have traffic from external of your network, only packets directed to the commonly abused reflection ports, and look at spikes when it comes to number of packets, not volume of traffic. Because here we're looking at the request going to the servers and not the actual attack traffic to the target. And then the number of unique destination IPs, which should be big. Group it by customer and device so that you know where that traffic is originated, and then run the query. So here's a result of one of those queries. We have grouped by customer. We have looked at the devices. And then in the red square, we see one of those spikes that we should be looking for. So we have a peak of unique destination addresses that comes out for a short period of time. So this is an evidence of a reflection attack. So for the second step, to drill down into that peak, we look only for packets for the UDP ports on the customer, on that particular customer's interface, and then we group by destination IP, AS number, and group by source port. And still, we're looking at the packets per second and the unique numbers of destination IPs. And I think we have a mistake. It should be source IP and ASNs and not destination AS. Sorry about that. Because then we have a result of that query here. And we're looking at IP addresses, and we're looking at the ASNs that they're coming from. So you see the top talkers here is Beeline in Kazakhstan, it's OVH Cloud, it's Microsoft, it's Verizon. And then you have to ask yourself that question. For this particular customer I have here, does it make sense that they have Microsoft or Verizon or Beeline Kazakhstan as their downstreams? You can even go and use some of your favorite tools to have a look at whether that customer might have a customers that are those networks. Or you can use your common sense, or both. But the likelihood is that that probably does not make sense, and this customer is allowing spoof traffic to come to your network. So then you go and you call this customer and say, hey, what the fuck are you doing? Or maybe you're more polite. And this is a little bit of what Aaron has experienced, is that the customer is sort of like, okay, I'll stop doing it towards you, but I'll send the traffic somewhere else. And or they can say, well, this is not those are not my addresses, so you can't make me responsible for sending this traffic. And network engineers are in general overworked and don't really know what to do. And I think Aaron have even created a bingo card of the excuses that he has gotten. So here is amplification pure response bingo. Our routers can't do RCLs, so we can't do this. I have called my customer and told them they're bad. This is the wrong time zone, so this is not our traffic. Or whatever. So what we're here for to do is that we would like a call to action. Please go out and do this. First of all, protect your own network and implement whatever you can implement of anti-spoofing means. If you run a network and you have downstream customers, make sure that you monitor what your customers are sending you if they're using spoofed addresses. And if they do, please reach out and teach them. You can send them this presentation if you want, or a link to the video or whatever. But just make sure that you will not be one of the people on the anti-spoofing bingo card. So, with that, questions, comments, or coffee?
Jan from Nordlys. So you talk a lot about blaming your customers, but actually I see a use case where you can kind of blame yourself, because if you are peering as well, then you will be able to see the same kind of traffic coming in from your peers. And if you see that, the server that is being abused for amplification of the spoof traffic will be within your network. And then you should go clean up your own beep. Just a comment.
That is a good comment, yes. All right. Well, early coffee this time. Thank you very much.
Thank you.